All right, you are welcome again. Today we are talking about numerical analysis, and under numerical analysis, we want to see how we can use Newton-Raphson formula. Okay, now let's take a look at the problem of today. We have derived the Newton's method for finding the inverse of a positive number. For finding inverse of a positive number, or you see 1 all over n, where n is greater than 0. Then hence find the inverse of 7, or 1 all over 7, using the initial approximation as 0.05. Okay, now let's go. We want to see how we can use Newton-Raphson to derive a formula for finding the inverse of a positive number, or 1 all over a number. Okay, this is what we want to use Newton-Raphson to do. Please pay attention. It's very simple. Let's see what we have to do. Now let's go. First, we are going to say let x equal to 1 all over n. We are looking for the root of a number. Okay, we want to find the root of the inverse of a number. So first of all, we say let x be this 1 all over n. Let x be the inverse of this number we are talking about. So from here, we want to make n the subject. First of all, we cross multiply. When you cross multiply, you're going to have xn is equal to 1. Then divide both sides by x. We are going to have n is equal to 1 all over x. Okay, now take n to the other side. When you take n to the other side, we are going to have 1 all over x minus n is equal to 0. So we regard this as our function f of x. Hello, we regard this as our function f of x. Yes, so this is the function or the equation we want to find the root. Okay, yes. Now from here, Newton-Raphson required a first derivative of the function. So let's go ahead and find the derivative of this function. So when we find the first derivative, it's going to give us f prime of x is equal to minus 1 all over x squared. Okay, minus 1 all over x squared. This is the derivative. So now let's go. What is the formula for Newton-Raphson? For a reminder, Newton-Raphson said xn plus 1 is equal to xn minus f of xn all over f prime of xn. So in this place now, we have our f of x already to be 1 all over x minus n, and then also f prime of x to be minus 1 all over x squared. Alright, good. Now let's fix these values that we have, the f of x and then the f prime of x, in the position where they belong. So placing them properly, we are going to say that we have xn plus 1 is equal to xn minus, in place of f of xn, we write 1 all over x minus n, and then all over, in place of f prime of xn, we have minus 1 all over x squared. Okay, good. We've written this, this numerator and the denominator can be written like this. Look at this. We have xn plus 1 is equal to xn minus, in bracket, 1 all over xn minus n divided by minus 1 all over x squared. Okay, so when you want to simplify this division sign will turn to multiplication, and then you will perform inversion. So the numerator will come down to the denominator, and the denominator will go up to the numerator. That is in the term in your right. Okay, so this is what we are going to have. We are going to have xn plus 1 is equal to xn minus, in bracket, 1 all over xn minus n times minus x squared all over 1, or you simply say minus x squared. Okay, good. Let's use this minus x squared to open the bracket. So when you open the bracket or multiply the bracket, we are going to have xn plus 1 is equal to xn minus open bracket. So when this minus x squared multiply the first term inside this bracket, which is 1 all over xn, is going to give you minus x squared all over xn plus, when this minus x squared multiply the n inside the bracket, is going to give you positive n x squared. All right, good. Now let's go. Let's use this minus to open the bracket. So, but before you open the bracket, look at the first time inside the bracket we have minus x squared all over xn. You see that we have the same x in the numerator and denominator. So one of the x in the denominator, we cancel one in the numerator. So we're going to be left with xn inside this bracket. Okay, so when you use the negative sign to open this bracket, we are going to have xn plus xn minus nx squared. Okay, yes. Now you see that we have xn plus xn is going to give us 2xn. Okay, then we have minus nx squared. Factor out xn. When we factor out xn, we're going to have 2 minus n xn. So here we have xn plus 1 is equal to xn open bracket 2 minus n xn. So this is the Newton's method for finding the inverse of a positive number. Hello. So this is the Newton's method for finding the inverse of a positive number. So you have your xn, you have your n, that's all. Now let's see how we can use this formula to easily find the inverse of a positive number. So let's see this example. We have the B part, say hence compute or find the inverse of 7, or we simply say 1 all over 7 using the initial approximation 0.05. okay, so here we have xn plus 1 is equal to xn open bracket 2 minus n xn. All right, so in this case we are going to start our first iterations. In Newton-Raphson, the n or iteration starts with n equal to 0. First iteration starts with n equal to 0. So in this Newton's method, if n is equal to 0, what are you going to have? Or when n is equal to 0, what are you going to have? So we're going to have x1 is equal to x0 open bracket 2 minus n x0. Good. So your x0 is your starter. The x0 is your what? Is your initial approximation. x0, your starter, or we say the initial approximation. Good. So here we have x0 is equal to 0.05, and then your n, which is the positive number you want to find the inverse, is 7. So now let's put it in here, where we have x1 is equal to x0 open bracket 2 minus n x0, where we have our x0 to be 0.05 and we have our n to be 7. So when you repeat, we are going to have x1 is equal to 0.05 open bracket 2 minus open bracket 7 times 0.05. okay, now when you say 7 times 0.05 is going to give you 0.35. okay, so when you say 2 minus 0.35, we are going to have 1.65. so 1.65 multiplied by 0.05, we are going to have 0.0825. hello. So here the first iteration that we have, we say that x1 is equal to 0.0825. This is the first iteration. Now we can go forth to do another iteration. Let's go for the second iteration. We say for n equal to 1. So in this formula where we have xn plus 1 is equal to xn open bracket 2 minus n xn. When n is equal to 1, what are we going to have? We are going to have x2 is equal to x1, open bracket, 2 minus n x1. And then x1 is what you have from your first iteration. And then your n remains the same. So here we have our x1 to be 0.0825. Our n remains 7. So let's impute here. Substituting, we have x2 is equal to 0.0825. In bracket, we have 2 minus 7 times 0.0825. So when you say 7 times 0.0825, you are going to have 0.5775. Then 2 minus 0.5775, we are going to have 1.4225. Then this 1.4225 multiplied by 0.0825, we are going to see that x2 is equal to 0.1174. 0.1174. So this is the second iteration. You continue like this until when you reach the criteria to stop, or the number of iterations you are asked to perform, you stop. All right, yes, this is how to use Newton-Raphson to derive the formula or the method for finding the inverse of a positive number. And then we derive the equation, and then we also put it into practice. Okay, we use the equation to find the inverse of 7. We perform 2 iterations. So this is all for this. All right, yes, thank you very much for watching. Let's pick more questions and then solve them. All right, yes, let's go.